Hi, we are Triton UAS. We are a student-run project team that designs, builds, tests, and flies our own autonomous airplane to compete each year in the AUVSI Student UAS competition against over 70 teams from around the world.
For the competition mission, there are a number of tasks that we must complete. The first task is to hit a series of waypoints in a specific sequence. While we're flying and hitting these waypoints, we want to avoid both stationary and dynamic obstacles. In our case, the dynamic obstacle is actually going to be another team's UAV that's also flying in the sky. While we're flying, we also have to fly over specific search area and classify ground targets.
We also need to drop a ground vehicle and have it land at one location and drive to a different location. To accomplish all these tests, we design and build our own flight platform, which has to carry computers, cameras, and communication equipment.
Because the project is interdisciplinary, we split the team into three sub-teams that have specific focuses. The airframe team designs and builds the flight platform. The embedded team sets up all the electronic devices on the plane. And the software team designs and implements all the software interfaces that we use on the plane.
Going more in depth on the airframe team, my name is Andrew and I'm the project manager and one of the airframe leads.
And I'm the other airframe lead. My name is Hubert. So the airframe team focuses on the designing and manufacturing of our flight platforms and our UGV. We currently have 3 projects. First, we are working on our 2 current aircrafts, the Swallow, as seen in that picture, and also our past flight platform, the Fiber One. We're also working on the unmanned ground vehicle that we will be dropping during the competition. And finally, we are in the process of designing a brand new flight platform that we will start manufacturing this year. So this is our current flight platform, the Swallow. We were able to have the aircraft flight ready last year, and we have conducted several test flights since then. We have made several improvements to the airframe. For example, we used SolidWorks and AutoCAD. These are 3D and 2D CAD softwares to design a vertical stabilizer reinforcement with the steerable tail wheel, like the one you see in the picture on the left. You can also see in the middle picture, we did composite manufacturing using fiberglass for those improvements. We also used MATLAB to perform analysis on the Swallow. And we will also be working on rebuilding and outfitting our past flight platform, the Fiber One, this year.
Another project we're working on is on the unmanned ground vehicle. So it has to carry a good amount of custom electronics. So what the airframe team's job is we design a custom chassis and we model it using SolidWorks, and then we 3D print it using Cura, which is a 3D printing software, and Wolfsbot 3D printer. We are also working on a project that is the design, analysis, and development of a completely new airframe. So we are currently in the process of preliminary design and performing design optimization in order to produce the best plane design possible. We are doing this using many different technologies, some of which are listed below, and hope to possibly have the new airframe ready for competition next year. So why should you join Triton UAS? Well, for one, you can be part of a team participating in an international student competition. You can learn about and contribute to some really cool projects, and you can gain valuable hands-on experience that could really help you in solving real-life problems. Students of all years are welcome, and no experience is required. If we only ask that you are willing to learn, and we will teach you what we can.
The embedded subteam is responsible for designing, building, and configuring the electronic systems that we need to make an autonomous airplane fly.
At the team, we split the projects mainly into 2 categories, those running at the payload and the other ones running at the ground control station. And at the payload, we have projects such as the power distribution board that powers electronic devices such as the onboard computer, the camera gimbal, and the flight controller, which is, in this case, a Pixar Cube, popularly used for autonomous vehicles. And we also work on the signals board, which handles all the communications. And this uses mainly an Arduino as its microcontroller for handling those tasks. And lastly, with the payload, we also have the unmanned ground vehicle, which uses PID libraries that are written in C++. And we also use MATLAB for testing the control systems running on the vehicle. And then at the ground control station, we also have the antenna tracker, which allows us to always have our Wi-Fi antenna at the ground control station pointing towards the plane for better communications. And for this antenna tracker, we're using a Raspberry Pi, and we're using also Python to program the controller running the antenna tracker. We also work on using the planning software while we're running missions for tuning the plane. And in this case, we use Mavlink packages to configure the parameters. And Mavlink packages are very helpful for us to have reliable small bandwidth packages that go to the plane.
So if you enjoy Triton UAS Embedded, you get to work on interesting projects like the aforementioned antenna tracker. You get to learn useful skills such as microcontroller programming, and you get to work hands-on with the internals of our aircraft. Come join us, it'll be fun.
The software subteam builds the software to fly the plane. We have 3 main projects that we work on. We use the ground control station to link all of our other services together and communicate with the plane. Our path planning takes a set of obstacles and objectives and plots a course for the plane to fly, and our computer vision handles identifying and classifying ground targets. The ground control station is the center of everything. We use it to upload mission files to our plane, as well as read telemetry coming back down from it. At the competition, we also use it as a bridge between our services and the judging servers to help submit our classified targets. It's a combination of front-end development using HTML, CSS, and React, as well as backend services with Go and Docker. We also use RGPilot to help tune additional parameters of the plane to improve its performance.
For the competition, we need to hit a series of waypoints, avoid some obstacles, and cover a large search area. Because we have a fixed wing plane, we need a complex path planning algorithm to accomplish all of these tasks in the most efficient manner. To accomplish these tasks, we use Mavlink protocol to communicate with the plane, and on the back end, we utilize Rust and Python. To classify the targets that are on the ground, we use a series of different computer vision tactics. Saliency for us is the process of taking the original full-size image and then cropping it down into a much smaller sized image. With this smaller cropped image, we can then segment out just the target and the character itself. From these, we can actually classify the shape, color, and alphanumeric character. These tasks are completed with a series of computer vision algorithms from OpenCV, as well as some machine learning algorithms from PyTorch. There are many reasons to join Triton UAS Software Team. 1, you get to be a part of a team participating in an international student competition. You also get hands-on experience with a variety of technologies such as full-stack web development, embedded Linux, computer vision and machine learning algorithms, and robotics controls. Students of all years are welcome, and there's no experience required.
We're also looking for new pilots for future school years because our current pilot, which is me, is graduating this year. You don't need any prior experience, but if you have any experience, that's definitely a plus. You will receive hands-on training from me, and we will provide all the training equipment such as the transmitter and RC trainer planes. You get to fly what you have built, and it's just a great overall experience for any potential aviation geek.
Thank you for listening. You can find us on our website at twas.ucsd.edu or Facebook at facebook.com/TritonUAS or our Medium at medium.com/TritonUAS.